Okay, here we go. Lesson 9.2. We are talking about special right triangles. So yesterday we began with the Pythagorean theorem and looked at different triples, famous ones. Today we're looking at just special ones. And there are two of them. First of all, reminder, what does it mean to be an isosceles triangle? So an isosceles triangle is one that has two sides that are congruent or equivalent. All right, that's going to come up today in our first special. We call it the 45, 45, 90. All right, and here is the triangle. So let me focus on here. So notice, again, we have a right triangle. So we got our little square there, designating that. We have an angle of 45 in each of those. So the rest of the 90 degrees is split into two. And we then have our two sides that are the same. And that would be x and x. So the question is, how do I find this side? We do know that x squared plus x squared will equal that hypotenuse side squared. Now remember, the hypotenuse, to find it, we'd have to take the square root of this side here. And you'll recall that if I add up these two things, notice we end up with 2 x squareds. And so now we can break this up from our days of algebra into two parts. I'm taking the square root of 2 times the square root of x squared is the hypotenuse. And hopefully you recognize that this guy here is actually just x, okay? So I have the square root of 2 times x. So how do I find the hypotenuse? I take the leg, which is x, times square root of 2. And the simpler way to write that is just x radical 2 or x root 2. You don't need to put the dot in between there. It's implied that there is multiplication. All right, so the leg times radical 2. And notice that's what it says here. The hypotenuse is radical 2 times as long as each leg. Our second and final special triangle is the 30-60. This is seen frequently out there in the real world. It shows up in a lot of different places. So let's look at this one. It's a little bit trickier. So notice again, we've got the 90. So we know the hypotenuse is over here. So we know this angle here has to be 30 degrees because these two angles need to be complementary. All right. The shorter side we always label as the unknown x. Reminder, the shorter side is opposite the smaller angle. So this is 30 degrees, and then that side is the shorter leg, x. So if I take x times 2, unlike this one problem up here, I'm not going to go through the proof of why it's true. We'll save that for another time. So I take the shorter leg times 2, and that's how I get my hypotenuse. So I multiply by 2. The longer leg, I take the shorter leg, x, and I multiply by radical 3. Okay, so to get to the long leg, I go x times radical 3. Again, I don't need to put the dot. I can just write x radical 3, and that means a multiplication. All right. Get comfortable with leaving answers in radicals and obviously simplified radicals. All right, so that's what that little paragraph there says. Some kids, they refer to this problem as the 1, 1, 2, but it's not 2, it's radical 2. And then this one they say is 1, 2, radical 3. Now be careful, if you do this, this is leg, 1x, 1x, and then this is the hypotenuse. What's weird about 1, 2, 3 is that this is the hypotenuse. It's the longer side. This is the leg, and this is the leg. So there's a lot of different ways to remember this theorem. You do you. All right, you get a problem? Identify it. Is it a right triangle? Yes, it is. Which of the special triangles is it? I see 45 degrees here. I know 45 degrees must be here. So this is the first case. So this is the x, this is x, and this is x root 2. Some kids like to write 1, 1, radical 2. So if this side is 10, then this side has to be 10, because it's isosceles. And then this side, I have to multiply by radical 2. So 10 radical 2. A little bit different in this case. First of all, the right angle is there, so the hypotenuse is sitting down here at the base. Again, I see that I've got two lengths, they're the same, so that means these two angles have to be the same. So therefore, this is the 45, 45. Again, to go from here to there, I have to multiply by radical 2. So radical 2 over 2 times radical 2. I know fractions aren't your favorite thing, but we're going to multiply. Radical 2 times radical 2 is radical 4 over 2. And you'll remember that radical 2 is just a fancy name for 2. So this answer is 1. So in my case, x equals 1. Which looks weird. Examples 3 and 4. Again, I see x and x. So this has to be an isosceles, right triangle. The difference here is now they've given me the hypotenuse. This is the h. I have to find the leg. So I'm not going to multiply. We need to divide. So how do I find x? I take the hypotenuse, 8 radical 2, and I divide by radical 2. You see what we end up with here? Just 8, because the radical 2's cancel. This one is going to be a little bit more challenging, similar to the last problem. Again, there's my right angle, so there's my hypotenuse. That's 45. So the other angle's got to be 45. So here, again, I've got to go from the hypotenuse to that. So again, we're doing division, yeah, by radical 2. So how do I get x? I take 12 divided by radical 2. Now you're going to have a really strong temptation to divide those two guys. Don't. This is inside the radical. The 12 is outside. So we have to, first of all, the process is called rationalizing the denominator. And here's what you're going to do. First of all, to get rid of the radical in the denominator, we're going to multiply by another radical 2. And to be fair, we have to multiply the top by radical 2. Notice this here is just 1, okay? I'm not changing what this is, I'm just changing the way it looks by multiplying by a fancy version of 1. Does that make sense? All right, so upstairs, easy peasy, we just put the 12 and the radical 2 together, because that's multiplication. Downstairs, we have radical 4. Radical 2 times radical 2. And you all remember that that is 2. Now, don't walk away from this quite yet, because hopefully now you can see, I have a 12 and a 2. I can simplify those two. Again, don't divide here, because that's inside and that's outside. But the 12 and the 2, yes, simplify that. So our final answer is 6 radical 2. Okay? And now for some examples. Notice there's some problems on the back side. We'll get there just a second. So this is the 30, 60, 90. Again, right angle, 30. So this must be 60. They gave us 15, the short side. How do I go from the short side to the long side? How do I go from the short side to the hypotenuse? So here we have to multiply by 2. Here we have to multiply by radical 3. So x. I take the 15, I multiply by radical 3. Done. Y. We take 15 times 2. So I get 30. Done. All right, question 6, a little bit more challenging because they gave us a hypotenuse. Again, right angle, 60 degrees. So then this has to be 30 degrees. So here is my short side. So I'm going from 22 to the short side. Well, notice in the last problem, we multiplied. So in this case, we're going to divide by 2. So how do I find y? I take 22, divide by 2, and I get 11. Check. How do I go to the long side? Long leg, we take 11 times radical 3. Check. This is the most challenging type of problem, where they give us the long leg. Again, 90 degrees, 60 degrees. So again, I'm going from here, from the 9 to the x, and then from x to the y, I think is the best way. Careful, going straight across or going, from the long leg to the hypotenuse, you can't do that. It's a little bit too complex. It's best to go through the short leg. So first thing we're going to do is, instead of multiplying, we're going to divide by radical 3. So x is equal to 9 divided by radical 3. All right, we did that right back up here, where we took the 12 and divided by radical 2. Same process now we're going to go through. So I've got to get rid of that radical in the denominator, so we multiply by radical 3 over radical 3. And you end up with 9 radical 3. 3 times 3 is 9, but radical 9 is just 3. So our final answer for x is, I'm going to simplify these two and get 3 radical 3. Y is a little bit easier now, because again, we're going to multiply by 2. So like that. So we take 3 radical 3 times 2. And when you multiply that, again, only combine the things that are on the outside with the outside. So 6 radical 3 is my y value. In this scenario here, they want you to round your answers. So when you get your radicals, go ahead and type them into your calculator. But they want you to find the area of triangle DEF. So we want to find the area of this whole thing. To do that, we need to find this distance and this distance, because area, as we will be discussing later on.
Have we created the test yet?
No.
Okay.
Yeah.
Thank you.
1/2 times base times height. So 1/2 times the base times the height. Okay, well, we got to figure these out in this case. Little puzzle. So this is a 30, 60, 90 triangle here. It's this special. And I've got the long leg. I've got to go from the long leg to the short leg. Okay? And the short leg in this case, I have to divide by radical 3. So 7 radical 3 divided by radical 3 is just 7. So I've discovered that this side is 7. I now know that this is 14. Why? Because I have to double it. All right. I now need to get the full length on the bottom. Do you remember from last chapter 8? If I have two parallel lines and I have these transversals, these pieces are broken up into proportional pieces. So notice 14, 14. So 7 root 3, and then this piece here would also need to be 7 root 3. So what is my total length and total width? Oh, well, hang on, before we do that, let's get this side over here. So this is 7, so there's going to be a 7 and a 7, so this is 14. All right, so my height we can see is 14. What is my base? What is my distance from here to here? All right, the base is equal to 7 root 3 plus 7 root 3. Be careful on these. What is 7 plus 7? 14. So we don't add the radical 3's. Treat it like a variable. So this is 7 of these things plus 7 of these things gives me 14 of these things. Final answer. We have 14 times 14 times a half. We're going to multiply those things together. If you grab a calculator and do 14 times 14 and then times a half, you should get something like 98 times radical 3. Now we need to have units on here because this just isn't a number. We actually know what we're measuring. So this is meters, and because it's an area, excuse me, it's meters squared. All right, so there's my area, 98 times radical 3 meters squared. Oops, they said round to the nearest tenth. So I'm going to grab my calculator, 98 times radical 3. And I get 169.7 meters squared. There's my real answer. In these problems here, you're going to actually have to draw the picture, first of all. They'll give you a description. So the length of the diagonal of a square. So we draw the square. And then we need a diagonal. And what do we know about that square? Well, we know that the length is 32. What do I have to find? I have to find the distance around. So I've got to add up all my sides. What do we remember about squares? Well, we've got a 90. It's a square. I know that these angles have been bisected, so they have to be the same. So this is the 45, 45. How do I go from the hypotenuse to the leg? That's the 45-90 rule. So to get the side, I have to take 32 divided by radical 2. Again, that radical 2 on the bottom is going to be a problem, so we're going to multiply by radical 2 over radical 2. So we get 32 radical 2 over radical 4. And radical 4 is just 2. And don't forget, we can now divide 32 by 2. So you get 16 radical 2. Now that's just the side. I've got 4 of them. So the perimeter is 4 times 16 radical 2. Right? All 4 sides, they're all the same. So 64 radical 2. Again, I look back at the problem. Are there any units? And I see inches. So this is inches. Let's see, does it say to round? Round answers to the nearest tenth. So 64 times radical 2. It's the worst part of the problem for me, is just doing this little calculation that I don't think is necessary, but book wants me to, so we'll do it. 90.5 inches. And isosceles triangle, $30, 30 degrees, not dollars, degrees base angles with an altitude of radical 3. Okay, I need an isosceles triangle. So I need a triangle with the 2 legs being the same. And the base angles are 30. All right, well, what is the, I could ask, like, what's this angle? But they give us one other thing, radical 3 is the altitude. Where is the altitude in this problem? And after a little thinking, you should realize this line here is the altitude line. It's perpendicular to the base, and it has to be radical 3 for a height. Okay? All right. Find the length of the base of the isosceles triangle. So we got to find this here. All right, well, what kind of triangle are we dealing with here? Notice I have a right triangle. It is a right triangle, and it's got a 30 degrees, so therefore it must have a 60 degrees. So we take radical 3. How do I go to the shorter side? You have to, is it multiply or divide? Now be careful. I think I drew this diagram incorrectly. It looks like I'm going to the shorter side. So I almost did this and went 1. But I think my diagram is really bad. Does this angle look like 30 degrees? Does this look like a 60-degree angle here? And the answer to that is no. So a better drawing would have been something like this. So here's my 30. Here's my radical 3. Yeah? And there's my 60 degree. So how do I go to that side? Well, that side is the longer side, right? And so we take, to get the longer side, we have to take radical 3 times radical 3, not divide. So we're going to get radical 9, which is 3. So my side, this piece is 3. Be careful, we shouldn't get too excited. This side over here, by symmetry, is going to be 3 as well. So my base will be 6. And again, it says meters, so I'll add the word meters. 6 meters. Okay, good luck in your homework. Hopefully it makes sense. Enjoy the day without Mr. Larson.